So, after I've introduced myself in the first talk, this talk is about migrating large-scale Cloud Foundry environments, which is something we've been doing for many, many years. We've been operating Cloud Foundry since late 2013, so we've been through it all. So in this talk, I'd like to share some methodological advice about how to approach a migration conceptually. Well, I'm still Julian Fischer, still running anynines. I think we can skip that part. So we're looking into migration from the perspective I'll explain in context, looking into how to migrate Cloud Foundry, the application part, and then also spend a few minutes talking about how to migrate data, which is often the part of the migration where you need to spend most of your brain time. So we're talking about Cloud Foundry environments that typically have hundreds or even thousands of application instances or applications. So classic Cloud Foundry environments tend to be very big because you need to, start a lot of VMs to make sense of it. So those Cloud Foundry environments who prevail, they usually have a certain minimum size. We're talking about classic Cloud Foundry here. I think some of the concepts could be applied to Core as well, but we're referring to Bosch, VMs, and Diego. And obviously, we want to look at data, because that's one of the critical aspects. So the scenarios we often see is either migrating an environment within the same infrastructure. For example, there's a network migration necessary, or because there's one Cloud Foundry flavor and customer wants to move to a different one, or customer wants to move from one infrastructure to another. Could be, for example, they want to move from, something like OpenStack to a public infrastructure, or the other way around, or from one public infrastructure to another because, better discounts, or sometimes you migrate from one infrastructure to another because of legal reasons. For example, you want to operate something under, in China, you want to operate something that's where the infrastructure is closer to the government because you have to. So it could be motivated like that. So in general, there's a pattern on how to do such a migration, and that pattern is pretty simple and straightforward. You have a source Cloud Foundry, you have a target Cloud Foundry, and you need to somehow interconnect the two, so your migration logic sits in between and needs access to both of the networks, which sometimes is very easy to accomplish and sometimes rather hard. But this is the assumption of the migration pattern. We also assume that there are some data services in the source system and some data services in the target system. Now, for example, if we migrate our own anynines platform, Cloud Foundry, and our anynines data services, that's rather simple because we have a homogeneous backup API and restore API. If you, for example, take some data services and you want to migrate it to a different version of data services on a different infrastructure, that can be much more tricky. So consider, for example, a Cloud Foundry on the left side. It uses AWS, and application developers are used to use data services provided by AWS, including vendor-specific message broker. And then you want to go to Microsoft Azure, where there's a different message broker with different API. You imagine that you need your application developers to take care of that change by changing the application itself. So this is not something you can do just like that. So the migration pattern in general means that you talk to the source Cloud Foundry, you read the objects you would like to transfer and write it to the target system. This can be as simple as straightforward as this: read it here, create it there. But some of the objects aren't as easy to transfer. For example, when you deal with UAA users, you basically have to create the UAA user first, obtain that identity, and then use that in the remainder of your script. So there are certain use cases where you have exceptions. So also, if you think about migration, the question is what motivates you? In scenarios where you have two different flavors of Cloud Foundry, it's often also the case that you have one version in the source system and a different version in the target system, which means that you may require object reformatting. So the objects you've read in the source system, they have a different structure in the target system, so you need to do some transformation, maybe adding information or transferring or transforming the information somehow. So you need to be aware of how the structures look in both API versions you're dealing with. So in general, it could also be necessary to perform a resource mapping. So if there are resources that you have to recreate, and that they'll get a different UID, and you have other resources depending on it, you need to somehow be able to understand what is the object in the source system and what's the new identity in the target system that you can refer to them. So in some cases, you need to look up resources to obtain the new identity in order to get the referential integrity right. So there's an example for application config objects. So here you get the space GUID from the app in the source Cloud Foundry. You get the space GUID from the source Cloud Foundry, get the org name from source Cloud Foundry, and then you find the org in the target Cloud Foundry by using the org name. That's possible because org names are unique within the Cloud Foundry, if I remember correctly. And then you find the space in the target Cloud Foundry by using the space name from the source Cloud Foundry and the org GUID from the target. This is exactly such an example where you need to get that referential integrity right. So you need to perform certain lookups in order to do that. Now, imagine your Cloud Foundry is still running. You need to perform a lot of API calls against the cloud controller. So this may have impact on the availability and the performance of your API endpoints as well. So something to keep in mind is maybe to start that migration logic when developers aren't in their rush hour. Another very important aspect of migration is dealing with the system domains and the application domains of a Cloud Foundry. So it really depends on the constraints of a project, but it could be that you want to use, or it's very likely that you want to use the same domains after the migration is done in the target system. So you need to provide temporary domains in order to have access to both systems simultaneously so that your migration logic can work. So you'd have to take care and be very conscious about where your production environment is. So in this case, we have the original domains still in the source network. The target network would be, the target Cloud Foundry is non-production, and your migration logic can access both systems. And we'll see in a few minutes why this is meaningful. It's also important to understand that it's not just that you have to reconfigure the domains, but you also need to ensure that all the certificates are being regenerated. So you need to delete the certificates, the existing certificates, and trigger the regeneration of those certificates. So if you take a large environment and they're running thousands of application instances, for example, when we make quotes for Cloud Foundry operations, the price scales in terabyte of memory for Diego cells. So it's often that these environments are, as I said, rather large. So if you read all the object data and you write it into the target system, this takes a while, takes even possibly days. As I said, what's the production system, and when do you do the switch over? So the way to do that is to do this in an iterative way. So you need to have a migration logic that allows you to do that. So in particular, the first run, if it's successful could be that you have to do this even several times because each migration comes with different constraints. Data services are vastly different, but even for applications, sometimes you figure out, oh, they are singleton apps. You cannot run them multiple times. You need to run them once. And not always do you find out those things before you run the migration logic. So you need to be prepared, as whenever you write code, that you need to rerun it several times. And it would be very ugly if you basically create a system that's entirely, damaged because referential integrity is totally broken, and you create duplicates. So in the ideal world, and this is how you should write your migration, is you run that migration logic with the production system, the source system being in production. You transfer the bulk of the data to the target system while the target system is still non-productive, and after that run, the overall data is already transferred. Well, as long as the source system is active, you will still have writes to applications, so there are state changes in both the applications. For example, applications could be created or they could be deleted. And application users will use the application, so that databases will change in state. However, you'd have, let's say, 80, 90, maybe even 95% of the state transferred in the target system, which is the part that takes a long time. So it can happen behind the curtain. Users won't really notice very much. So the last run will then be of a short runtime. I'm talking about a comparatively short runtime. Could still take an hour or two or several hours, but it will come with a small downtime. And the goal of this step would be to sync to completion and then do the switch over. So the next requirement that comes from that idea or that approach is that you need to implement your actions in an idempotent way, which basically means that you avoid creating duplicates, or that whenever you reapply it, that when an object has created, that you ensure that this change is reflected in the target system properly. It sounds easier than done, because especially when you need to take care of those associations between objects like the UAA users and whatever the objects are attached to it, you need to ensure that this is done in a consistent way. Which brings us to the question how to deal with data. We've learned taking the Cloud Foundry objects from the Cloud Foundry API, reading them. You need to be aware on how the relationships between the entities are. You need to do that in an idempotent way and transfer it to the target system. Fine. But applications, if they are 12-factor compliant, they have backing services where the state is stored. So how many assumptions can we make about data services in Cloud Foundry? Basically none. It could be user-provided services, could be service brokers integrated in Cloud Foundry, and you don't know, at this point when we talk about this topic, what do we know about the service brokers? Nothing. Could be a service broker that issues credentials, could be a service broker that does virtual machine automation like we do with our anynines data services, could be anything else, could be something that is actually managed by the infrastructure provider. So this is something you really need to figure out, is what are the data services you're looking at in the target and in, of course, in the source system, and how do they map? So if you want to move from AWS to Azure, good luck with that. Because there's likely to be your application developers involved in that migration very intensely. If you're lucky enough and you have data services that exist in both variants, in both source and the target system, well, then a mapping is possible, and you can follow a similar approach by reading data from the source system, writing it in the target system. Basically, you have to recreate the service instances and somehow have a backup restore. So the migration pattern is basically the same. But in general, the data service challenge, is for modern platforms is that it's even harder to solve than unifying the operation of stateless applications. I mean, it's quite obvious. You have to deal with state. And after the NoSQL movement, the number of different database types has exploded. So now there are more databases you can count. And as an application developer, you could spend the rest of your life learning new data services. And each data service, has a different query interface, has a different way of storing data, has a different way of replicating data. But at some point, if you do a migration, you need to analyze what are the data services you're looking at, and what are the assumptions that you can make about them? Is there somehow a unified way of dealing backup and restore? The worst case is that you have to make a backup and restore story for each of the data services being involved. So hopefully there's already tooling you can use, but still this will be a lot of scripting. So state leads to heterogeneity in data services because they all do things a bit differently. However, there are commonalities. But if you look at this list of databases, and this is just relational database management systems, you can already get the magnitude of this. So usually organizations using Cloud Foundry, they don't have that number of data services because integrating them in Cloud Foundry requires time. So there is a limited number. I don't know, something between 5 and 20 data services maybe. So this heterogeneity also affects the backup and restore strategies, which makes the migration also, it makes you think about how to do backups and restore in a generic way. The most basic way to do backups would be to dump the schema and restore the schema. For example, RabbitMQ. Depending on how you use RabbitMQ, it could be an in-memory use case where all you want to do is just get the messages queues replicated and have them set up in the same way it was in the source system. But with databases, you also want to transfer the data. And the most simple approach would be to take a dump and restore the dump. Now think about idempotency. So you want to be able to do that repeatedly. So let's say you have a database with a lot of data. You take a dump is going to be big. Restoring the dump is going to take a lot of time. If you want to do the last run, do you transfer a diff or do you transfer another dump? So if you want to have a fast migration, you have to think about backup and restore in a more efficient way or you have to live with a longer downtime during the synchronization of your data service instances. So if you, for example, think about automation and what's possible on technical level, you could, for example, have a Postgres with asynchronous streaming replication to a remote offsite location where you already have a service instance and you'd continuously do asynchronous replication to that instance, which makes the switch over much easier. But first of all, barely any automation can do that. And second, this is data service specific. So if you want to do that, not every data service will give you the chances to do so. And then you have service bindings, which is the relationship between the application and its data service instance. And it's basically metadata stored in the cloud controller, but also maybe in the service broker itself. So for example, we store the data in the service broker, which is structurally similar to what's stored in the cloud controller, to be able to have data service automation that is to some degree independent from the Cloud Foundry environment. So you could, for example, take one Cloud Foundry away, add another Cloud Foundry and use the same service instances without needing to move them because they run in a different network segment. So the structure of the service bindings obviously are also very specific to the service broker implementation, so making assumptions about them is hard. So let's say you have one service broker in the source system, let's say an AWS service broker, because it was so convenient to use it, because you don't have to deal with data service then anymore, and now you want to go to Azure, they also have a service broker, but the credentials look very differently. So although you're talking about, let's say, Postgres, which is somehow a protocol for relational databases these days, you may have to adapt your applications because the way you read the VCAP services structure will be different. So it could also be if you think about data services, that, for example, in our data service is that you have a console which also gives you internal domain names, and when you migrate data services, you have a similar challenge with changing the internal domains of the console compared to the application and system domains in Cloud Foundry. So it's not a big deal, but you have to take care of it. So here you could also just recreate service binding on the other side, but still your application code may have to be changed, and also you need to sync the data accordingly. So in general, you need to worry about data consistency, which means in the most simple approach, you'd accept a certain downtime, you put Cloud Foundry on a lockdown, and block the API access to Cloud Foundry API, maybe even to the database instances, and just allow the migration tool to do its magic. So during that time frame, so even in large environments, this is a couple of hours usually. So in a time when there's little usage, you basically shut down the API, you make your last run, sync the last state over, and then you make the switcheroo to the new system, which boils down to migration day. At this point, you've already executed the migration logic for the first time, which means the vast majority of state has already been synced to the target system. Then you disable the Cloud Foundry API, you run the final migration. There could be some post steps here, for example, if you have singleton apps that need to be stopped in the source system. You start apps in the target environment, make sure that they're all running, which again, it's very helpful to have some kind of monitoring that the workload is still there. If you had just developers pushing to Cloud Foundry with no monitoring, well, how could you know that everything is up and running as expected? So reconfiguring the Cloud Foundry target by changing the domain, keeping in mind the certificates, and then cut over the traffic from one Cloud Foundry to another one. Your monitoring should tell you that everything went fine, and you'd be the hero of the day. So we've done this, I don't know, a dozen of times or even more over the years. Usually these projects, they have a certain project character, which means that we have a lot of automation to do that, but it's basically coding every single time. So you have to make this analysis. You go through the list of, you have to take care of the advice presented here, and usually you'll be fine. So it's possible to migrate large environments from one infrastructure to another, or one Cloud Foundry to another, without large impact and huge impact on the applications, which, in my opinion, is a strong case for classic Cloud Foundry. So to this day, I'm thinking about organizations who've adopted Kubernetes, which is a wonderful technology, but think about migrating a landscape of Kubernetes clusters, let's say 100 of them or 50 of them, with application loads, and think about migrating that from one infrastructure to another. I'd say that migration path has a very different magnitude of complexity than this one. And it is possible to do that. We've done this many times, as I said, and the downtime is usually kept to a few hours. So I'm CEO. My technical abilities these days are very limited, but I can assure you, here are the guys who do that for a living. They wear Cloud Foundry. They currently hide over somewhere here. And if you have painful, detailed questions, you just approach them and ask them right away. I'm pretty sure you'd get a very verbose answer. So thank you very much for your attention today, and see you maybe in the next session.